Good morning, students. In last class, we discussed about various properties of law decomposition. In that, we discussed only what do you mean by lossless joint decomposition, right? And in this second property, we are going to discuss about what do you mean by dependency preservation. Okay, so dependency preservation is based upon what we call as functional dependencies. Based upon the constraints of functional dependency, we can use dependency preservation. Whereas while using the uh, lossless join property, we use natural join between two or more relations so that we can get exact data. Whereas this dependency preservation is we use functional dependency. Based upon the functional dependency, we can retrieve our relation. Okay. Combining two or more relations by means of natural join is a very huge task, and also it takes some time. Okay, so it is also very expensive. So based upon this constraint, we can use additional property called as dependency preservation. Okay, so it is an important constraint on the database. So every dependency must be satisfied by at least one decomposed table. So we are dividing two or more relations. If you want to combine two or more relations, means you have to use what we call as dependency constraints. So based upon one dependency constraint, you can retrieve two or more relations, a combination of two relations. Okay, if A to B, how you can use the particular satisfaction of the constraint means if A to B holds, then two sets are functional dependent. Okay, by means of A to B, either B to A or A to B, these are the two functional dependent, and it becomes more useful for checking the dependency easily if both sets in a same relation. So if you want to if you want to combine two or more relations based upon the dependency, it is very useful to get a single relation. Okay, so the decomposition property can only be done by maintaining the functional dependency. Previously, we discussed that dependency preservation can be maintained by means of functional dependency. Okay, next. So we can use another definition. This is the definition of the dependency. Loss of getting how you can use this particular dependency preservation is we can easily understand by means of this definition. That is, getting lossless decomposition is necessary. Okay, but of course we also want to keep dependencies, since losing a dependency means that the corresponding constraint can be checked only through natural join of the appropriate resultant relation in the decomposition. That is, we are using the first property called as lossless join. If you are decomposing two or more relations, we don't have any functional dependency, means you are getting by means of natural join, so that I have 5 decomposed data. If I decomposed data want to combine single scenario, you use 5 natural joins so that you will get a retrieved original relation. But instead of using 5 natural joins of lossless join decomposition, just based upon the dependency preservation, you can easily retrieve your data. So that we are saying that lossless join decomposition is a expensive process. Okay, so it results in relation in the decomposition. This would be very expensive, as previously we discussed. Our aim is to get a lossless dependency preserving decomposition. Let me see an example. I have a relation called R, which consists of 3 attributes called A, B, C. So that if I have two dependencies in a particular relation called A to B and B to C. So if you're dividing this relation, so that I will get two relations called A to C one relation and B to C another relation. So, but the functional dependencies are A to B and B to C. So does this decomposition preserving the given dependencies, so that you can check the in first relations we have, this is the first relation. In first relation we have various functional dependencies called A to A, C to C, and A to C, and AC to AC. We have four dependencies has to follow. Similarly, if you take the B to C dependencies, we have 4. Okay, but the set of non-trivial dependencies hold on R1 and R2. they get the data called as A to C and B to C. This is the A to C and this is the B to C. If I want to get A to B, if I want to get additional dependency called A to B, it cannot be derived from F to B because we have the B to C and A to C. There is no combination of A to B. So this decomposition is not dependency preserving. We are not getting A to B dependency by combining two or more relations. Okay, this is not a decomposite relation. Now you have to use any one of the constraint to get A to B. Okay, right. I have the relation ABC. You have the combinations of A to B and B to C. Here also A to B and B to C. Okay, now the relation is divided into AB and BC. Here see, in this above example, we have the dependency called AC, BC. Now this example, I have AB and BC. AB and BC. So that AB has these possibilities and BC has various 4 decomposition possibilities. Now, the important concept here is, now you have to use one preservation constraint. The preservation constraint is union. Whereas in the lossless join, we use the natural join property. Here, dependency preserving, you are using union property. That is, you are combining 4 or 5 relations. We can directly get the data. Instead of combining one at a time, you can combine 4 or 5 particular decomposed relations at a time. So that by means of union this function, I will get A to B and B to C. So in F, all the original dependencies occur. Our dependencies are A to B, B to C. We will get A to B and B to C. So this decomposition preserves dependencies. Okay, B to C. Now you see this one. If I want relation A to C, B to C, this is the A to C and B to C. Now you are getting A to C and B to C, but we are not deriving A to B. But here we can, by means of union operation, you are getting A to B and B to C. Similarly, A to C can also possible. Okay, right. I hope you understand the particular what you call lossless join decomposition and dependency preserving property. Okay, right. Last topic is surrogate key. See, already you know about different keys called as primary key, candidate key, composite key, and what we call not null key and unary key. All comes under, we have the unique key. So we have various keys. But what do you mean by surrogate key? Surrogate key is an artificial key, whereas primary key is a natural key. So defaultly we have one primary key and remaining the various keys. But the DBMS defaultly generate artificial key called as surrogate key. For example, it is also one of the primary unique key attribute property. For example, in your relation called student table, SID is a particular primary key. College code is also unique key, so that defaultly, if any use of particular relation which use a college code, that college code is act as a surrogate key because it is also a primary key property and it has a possibility of unique key constraint. If you take Aadhaar card, this is also called as a, if you are not giving a primary key constraint in your relation, defaultly the system can generate one unique identifier key as a surrogate key. Okay, that is called as surrogate key. Artificial unique identification of particular row is called as surrogate key. Okay, the surrogate key is just unique identifier for each row and it make use as primary key. But there is only requirement for a surrogate primary key, which is that each row must have a unique value for that column. A surrogate key is also known as artificial key or identity key. It can be used in what we call as data warehouse. Okay, it has following characteristics called unique value, and it is generated by the system, not as human. Okay, see, primary key, unique key, not null, these are given by the user, whereas the surrogate key is done by the particular system only. It other words automatically generated. The key is not visible to user. We cannot see particular surrogate key. It is not composed of multiple keys. We cannot combine 2 or more keys to get a particular value. There is no semantic meaning of particular key. Okay, we don't have any meaning. Generally, a surrogate key is a sequential unique number generated by SQL server of the database itself. Okay. For example, if you take one of the best example of your surrogate key is your transaction of your any payment of your what you call any shopping mall. If you are purchasing something else in a shopping mall, if you are paying the bill, automatically you will get a particular ID. That ID is generated by the system. That key, that unique identifier number, the transaction number is of your particular payment receipt is act as a surrogate key. I hope you understand the concept of surrogate key. Okay, there is a slight difference between a surrogate key and a primary key. Ideally, each row has a primary key and surrogate key. The primary key identifies the unique row in the database, while the surrogate key identifies the unique entity in the model. Unique entity in the model means if you are transacting particular transactions or particular items in your particular purchasing order, that is one transaction and it is a unique identity in the model. Okay, so we have example of surrogate key is to the column in SQL server, next global unique identifier, next universal unique identifier. We have, for implementing surrogate key, we have two phases. One is auto incremental and manual incremental. Auto incremental is a process that was done in shopping systems, whereas manual increment can be implemented by means of some filing system by the user. Okay, so we have various advantages of the surrogate key. It does not change, so the application cannot lose the reference in the document, other database. If the primary key is changed, then the related foreign key does not change across the database because the surrogate key is used as a reference key. Simply, we can say that the surrogate value is never changed, so the foreign key values become stable. So it is most often a compact data such as an integer. It is less expensive in a join than the compound key. And finally, business logic does not something in this key. So defaultly, any business parameters cannot be used in this particular surrogate key. I hope you understand this session. Tomorrow we will make a revision or completion of the fourth unit. Now we complete the fourth unit. So next class either we are going to fifth unit or you can make a revision. Okay. Thank you all.